Hello and welcome to Physics Problems One by One. So here is a problem. As always, read it, maybe once, maybe twice, and then pause the video and try to solve it yourself. So we have a free fall body, and it starts with zero speed, v0 equals 0, and it covers some distance h. And last second, and I will denote 1 second as a tau. Let's use a tau letter, Greek letter, not T, but tau, the predecessor of Latin T, tau. So let's put this time as a tau, and during this last, and tau is 1 second, but I will use a character. And during this second, it covers h over 3, right? This distance is equal h over 3. So h is the total distance as always, and this is this distance during this time tau. So what can we do? Of course we have distance. In this distance we want to write the formula. And of course we have times. Let's put the full time as T capital, right? And that's what, because this is what they want us to find, right? So what can we do? Well, we solved those problems already several times. So if we have this distance and this distance, then we know this distance too. And the time, if this is t and this is tau, then this time is t minus tau, right? Okay, and now we're dealing with this period, with this distance. So we start with v0, and for this distance we have this would be v final and this would be v initial. And of course we can write v initial equals cos, correct, v0, which is 0, so I don't write it, plus acceleration g over the time it traveled, t minus tau. And of course I can do the correct, I can write the same formula for v final. And v final would be exactly the same, only it covers from here to here, so it would be g multiplied by t, right? And those are two formulas. And then why I wrote v initial and v final? Well, of course I want to connect it with this d. So I write d equals, if I know initial and final, what formula we will use? Absolutely correct. I will use v final squared minus v initial squared divided over 2g. And this would be everything that I want to do. And so now becomes simple mathematics, right? The only thing I want to use the full h. And I have to count unknown as vf and vi, and t is unknown, and d is unknown, right? So I need one more equation, and of course I have this equation because this is 1/3, right? So d actually, I know that d actually is 1/3 of the pool this. And if I know t, I can write it as gt squared over 2. And now I have 4 equations and everything becomes very simple. Now for example, I write v initial, v final, I put them straight here. And instead of d, I put this. So I do several things at once because I don't want to rewrite what I already have. So watch, v final will go here, v initial will go here, d will go here. And this way I will get rid of v final, v initial, and d. And all I will have is something that contains known numbers plus t that they want us to find. Again, physics is over here. The whole physics is this. V at that point, and this is initial for this interval, for this distance, is this. V final, again, final for this is gt because it travels time t from here to here with acceleration g. D is this distance based on this final and this initial. Physics is over. Last thing is that they tell us that this distance, if we know t, the distance is gt squared over 2, it's 1/3 of it. So now physics is over, it's only mathematics. Solving 4 equations with 4 unknowns, get rid of this, this, and this is one shot. So follow me and correct me if I'm wrong. So instead of d, I write this immediately. gt squared over 6. 1, 3, 2, 6. I put this d here and that's it. Equals. V final would be g squared t squared. Right? Minus V initial will be g squared, and instead of the brackets it would be t minus tau squared, right? And then I have to divide over 2g. Okay? So now we have one equation, and let's solve it. For example, let's get rid of denominator. We will send this here and this we will send here. It's very easy. So I'll continue here. So 2g goes here, 2 and 2. So 2 will not go, 3 will go because 2 is actually will be cancelled with 6. 6 is 3 multiplied by 2. So it would be 2 is not going, so we have g squared t squared equals, and here we have 3 multiply, and here let me open the brackets. So 3 would be g squared t squared minus g squared, and here inside the brackets it would be t squared minus t2, this would be a formula a minus b squared. Let me remind you, it would be a squared minus 2ab plus b squared, right? A is t, tau is b. So, plus there is minus, so it's changing the signs all the time. So this would be g squared 2g squared t tau. And then tau squared, it would be minus g squared tau squared, right? And then I have to close it. And then I have to continue. And I will continue here. I have g squared t squared. And I put 3 as is for the time being, because I don't want to do too many things at once. This would be gone. And this will stay. It would be 2g squared t tau, and this would be plus and this would be minus g squared tau squared. Okay, let's open the brackets, and we will have g squared t squared equals 3 multiplied by 2 would be 6, right? 6g squared t tau, right? Minus 3g squared tau squared. I see that g squared everywhere. I can factor it out and I can get rid of it. T squared equals 6t tau minus 3 tau squared. So recall, this is one equation, tau is given, tau is 1 second, and t is unknown. As it should be, we get rid of those 3 equations, we get one equation with t capital only. And this was this equation, and this is just transformation. So this is a square equation, And to solve the square equation, we put t squared minus 6t tau plus 3 tau squared equals 0. And let's put tau equal 1, and we will have t squared minus 6t plus 3 equals 0. And this is quadratic equation. And how do we solve quadratic equations? Of course, to solve quadratic equation, we have the formula ax squared plus bx plus c equals 0. And we have, let's continue writing here. And for this quadratic equation, we will have x12 equals minus b plus minus square root b squared minus 4ac. If you don't know it, I probably have to make a course, Math for Physics, Basic Algebra. But for now, I believe that you know it. Divided over 2a. And this is a formula. And in this case, instead of x, we have t, so we write t12 equals. Instead of a is not acceleration, no nothing. A is what stands in front of square. And the front of square stands 1. So a is 1. B is what stands here, minus 6. So it would be minus plus minus, it would be 6. Right? Plus minus b squared, it would be 36. Minus 4, instead of a, it's 1. And instead of c, it's 3. And we have this. And then, obviously, we want only positive solution. And so we write t1 equals 2, 6, 36 minus 12. It would be 24. Plus minus square root of 24. 24 is almost 5. Almost 5. So let's put 5. Unless it would be, with your calculator will show that it's a little bit less. But my calculator in my brain, it doesn't have a lot of resolution. So for me, square root of 25 is roughly 6 plus 5 divided over 2. And it would be 11 over 2. And T1 would be 5.5. In reality, it would be a little bit less. I suspect, like, from my experience, it would be 5.45 or something. But basically, we found the time that it requires for the body to come from here to here is free falling, and all we know that in the last second it covered 1/3 of this distance. And all we did, we wrote only the formulas about free fall that we by now should know very well. And then we solved the system of 4 equations with 4 unknown, getting rid of 3 very fast and solving only the ones that they ask us, T capital. Subscribe, bell, like, question, comment, ask your problem. Thank you very much. See you next time.